Let's start with the property of selection. And the property that I'm talking about is, I want to select 3 out of 5. And the 5 of them, let me name them, is A, B, C, D and E. In how many different ways can I select 3 out of 5? Let's write, we know the answer or so on is nothing but 5C 3 ways. Let me write it at the top itself. The answer is 5C 3 ways, but this is only in terms of speaking. Let's write a few of those ways. So one of the way could be that I select A, B and C. Since it's a selection, I'll just put them in a bracket. Another way could be I select A, B and D. So the members have to change. A few more, there could be many of them, and one particular way is, let's say B, C and E and so on. The property that I'm trying to highlight here is, if I have made a selection of A, B and C, does it result, which are the people who are left over? Could I say A, B, C are selected and hence D and E are not selected or are leftovers? A, B, D are selected here and hence the ones which are left out is C and E. B, C, E, so who is not selected? A and D. Could I say, if all of them are different ways of selecting, could I say the team that is left over is also going to be different? So could I say there's a one-to-one correspondence out over here, and it's as good as instead of selecting 3, could I say these 2 are named such that they are not selected, that is 5C2. 2 people are selected not to be in the team. So could I have a relation here? Clearly 5C2 is equal to, or 5C3 is equal to 5C2. In a general notation, if I want to write, any NCR, your selected R people, is as good as saying the others are not selected. How many others? They would be N minus R, and we would have the general relation NCR is equal to NC N minus R. Right? Okay. This is the property of combination. We don't need the left part, so I'll just erase this. We'll do this in later part in a calculation bit and again learn it up. Let's see the link between selection and arrangement. I've already drawn your attention to the fact that quite a few of us think of arrangement as selection first and then arrange. This is nothing wrong. That time also I mentioned, I just said the whole process is called an arrangement, so don't use 2 different words. So let's say I want to arrange 3 out of 5. I want to arrange 3 out of 5. Could I use the same process and say, let me first select? And in how many ways could I select? I could select them in 5C3 ways. Having selected this, is my job over after selecting? Not really. I have to arrange. So in how many ways can I arrange A, B, C? Let's look at the whole process. Sorry, once again. 5 people make a selection of 3. So now I have to consider only these 3. But then I have to arrange. And in how many ways can I arrange them? Could I say the arrangement could be, now A, B, C is going to be different from A, C, B. Similarly, with the same 3 members, how many different arrangements could I have? CA as well as start with CAB and CBA. Could I take another team and could this again be arranged in more ways? Amongst themselves. The BCE 3 arranged among themselves is nothing but 3 factorial, that is 6 ways. Right? So could I say each of this 5C3 is multiplied by a 3 factorial to give us the number of arrangements 5P3. That is the relation between an arrangement and selection as such, right? So let's see this in a general way. Here we had numbers, so let's just see that in a general way. I want to select R out of N, and this is written as NCR. Compare it with arrange R out of N. We know it written it is NPR, but we saw that this could always be thought as first do the selection. So R of them were there, we need to arrange a few of them, so first select them. That can be done in R ways. Is my job over? No. Further, after selection and continue. You have R objects. What do you do with these R objects? You'll have to arrange them amongst themselves. R objects among themselves could be arranged in R factorial ways. So this is the linkage again in a general terms. So we could also rewrite this as NCR is equal to NPR divided by R factorial, just taking it to the other side. So from a combination you should be able to go to a selection, from a selection you should be able to go to an arrangement in that case, right? Combination you should go to an arrangement you could go to a selection as such, right? So we have learned the notation, we have learned the linkages. The last job left is how do I calculate? Well, I've kept it for the last because we have done many videos and we have already found the number of ways of arranging, right? So I'll just be a little quick out over there. Let's say the process is how do I calculate NPR? What is NPR? NPR is I have to arrange R, and since it's an arrangement, I'm just drawing positions. How many are these? These are R of them. R positions. In how many ways could I fill in the first position? N ways. I have N objects. The first way could be filled in N ways in general. The second one could be filled in N minus 1 ways, in N minus 2 ways, and so on it would continue. And what do? I take the product. This is how we have formed numbers. We have seated people, arranged alphabets. So if all of them are distinct, I don't have to do any correction, and this is going to be my answer. So the value of NPR is nothing but start with an N, continue multiplying with that N minus 1, N minus 2, keep reducing it by 1, till what value will you continue? Such that there are R factors. You could also find the last term using these terms, but I would simply say just count how many factors are there. This is going to be an NPR. And if you know an NPR, do we also know how to calculate an NCR? NCR is nothing but an NPR divided by R factorial. How do I calculate the numerator? We just saw N into N minus 1 into N minus 2 and so on. How many times? I'll just say R factors. This divided by R factorial. So writing it in this way, 1, 2 into 3 into 4. Again, how many of them? R factors. That is going to be R factorial. I hope this is clear. This is how we will calculate. We also need to know a definition, or let me just use an example. When we are finding number of arrangements, quite often we end up with multiplications of this type, 5 into 7, 7 into 6 into 5 into 4, let's say. How do I generalize this? Does this remind you of something like a factorial, or if I take it to its logical conclusion, could I say this is a factorial, which is nothing but 7 factorial? But I do not have this. I just am interested in 7 into 6 into 5 into 4. So how do I get rid of that? I get rid of that just by dividing it by whatever I don't want. So this will cancel out with this, right? So could I say 7, 6, 5, 4 is nothing but 7 factorial by 3 factorial? Right? Why do I not want 3? 3 terms I don't want. Rather, I want 4 terms, so 3 I don't want. I'll write this in a general way. N into N minus 1 into N minus 2 and so on continued. I want only R factors or R terms. If I take it to its logical conclusion till 1, I could denote this as N factorial. But then here now there are going to be n terms, and I require r of them. So these I do not require. How many will these be? N minus r terms. These are the ones that I do not require. So what do? I divide it by an n minus r factorial. Hope you have got the logic out over there. So let's write finally. To speak, we use NPR. By definition, you should know this is going to be n factorial by n minus r factorial. However, to calculate it, you would have to use the way we have been doing questions, that is continuing with this way and so on r factors. Similarly, NCR, the formula should arrive from NPR itself. Write the NPR itself. By definition, it is going to be n minus r factorial. We divide it further by an r factorial, so into r factorial. And to calculate, we do the same thing, n into n minus 1 into n minus 2 and so on over r factorial. R factorial is nothing but 1 into 3 into so on. It is understood that the numerator denominator will have r factors out over there. Can we look at, so we were forming the team. From 16 players, we were forming a team. Team is a C of 11 players. Now 11 is a pretty large number. So let me just do this calculation first. How many times will I write this? I'll write this 11 times. So let me quickly write this sort of 11 times and see what does it turn out to be. 9, 8, 7, am I through? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. In your mind, you should look at it when I write such a term, I've arranged the players. The first batsman could be in 16 ways, the second in 15 ways, 14 ways. So this is an arrangement. I want a selection. So I would divide it by 11 factorial. And what is that 11 factorial? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. And if you write all this, you see not only have I unnecessarily written a lot of them, but all of them also get cancelled out. So 11 into 10 into 9 into 8 or 6 can be cancelled out over here. And what are you left with? 1, 2, 3, 4, 5 terms. And in the denominator, do you have a 5 factorial? Which is exactly similar to a 16C5. Right? And isn't this, we have already seen this, NCR is equal to NC n minus R. So whenever you have a very large number of selections, it's much better to work with which are not selected in that case. Hope this video makes it very clear about all the standard notations. We did not do questions out over here for the simple reason questions have to be done with a different logic. This entire video was only for us to communicate well enough in the standard textbook language of an NPR, NCR, the notations and so on. Next videos we will continue with application or questions on combinations.